Alright, today's lesson is about factoring the difference of two squares. Something I actually really enjoy doing. That's because I'm a nerdy math teacher, but I think you'll find this a little bit easier than the sum and product chart, and in some ways even easier than perfect square trinomials. So, just like it reads, the difference of two squares, difference we know is subtraction sign, and separating two squares. So we're talking about, the first time we're going to be factoring a binomial. But an example of the difference of two squares would be, say, x squared minus 9. It is literally the difference of two perfect squares. So another example would be 9x squared minus 36, 49 minus even x to the fourth, right? Because x to the fourth is still a perfect square, because it's x squared times x squared. They are going to have a unique type of factorization similar to a perfect square trinomial, but slightly different. So that's a perfect square trinomial, and I'm going to juxtapose that with the difference of two squares. We know this factors into the square root of the first term, sine of the second term, square root of the third term, squared. Perfect square trinomials factors into what we call the sum and difference. So they look very similar, x and x, 3 and 3, but one's got a positive and one's got a negative. So square roots of the first terms in the first, square roots of the second term in the last. One's positive and one's negative, and you notice when you do the FOIL, the outside and the inside parts of the FOIL are going to cancel out, and that's why it equals just a binomial and not the typical trinomial. So let's do a few examples. 25 minus y squared. Ask yourself, is that the difference of two squares? Well, it's certainly the difference of perfect square, so we're going to say, okay, two binomials. Square root of 25 is 5, square root of y squared is y. One is plus, one is minus. Padoop. 64, x to the fourth, minus 9. Are they both perfect squares? Sure. 8x squared, 8x squared. 9 is 3 and 3. One is plus, one is minus. X squared plus 100. Difference of squares? No. Can't be factored, because there's no such thing as the sum of two squares. You can only factor when it is the difference. So if this would have been x squared minus 100, different story. Good to go. xx, 10, 10, 1 plus, 1 minus. The order of the plus and minus makes no difference. The other thing we got to look for too is when you're doing difference of two squares, you've always got to check for GCF first. And here's what I mean by that. Say you had 9a squared b squared minus 36x to the fourth. Notice that both are factorable. Both have a greatest common factor of 9. So before you approach the problem, you've got to factor the greatest factor out. And now, do we have the difference of two squares still? We do. Minus 2x and ab plus 2x. So I've got a couple more examples. Some have that and some don't. 49 x squared y squared minus 100 z squared y squared. Well, 49 and 100 do not have a common factor, but notice they both have the common factor of y squared. So we're going to factor that out first. That is our GCF. Then check, do we have the difference of two squares? I believe that we do. 7x, 7x, 10z, and 10z, one's plus, one's minus. And you are factoring the difference of two squares. 72x squared minus 18. I believe they are both factors of 18. That leaves you 4x squared. Excuse me. And 18 goes into itself one time, but 1 is in fact a perfect square because it's 1 times 1, so 2x minus 1, 2x plus 1. X to the 10th minus 4y to the 20th. They're strange looking. They're big, but they're perfect squares. And then I want to show you one thing that's really kind of a different kind of thing. It's going to be the difference of squares. That sounds kind of weird. I'll show you. An example would be x to the 4th minus 16. Ask yourself, is this the difference of two squares? And it is, so it's factorable. So we're going to factor that to x squared minus 4 and x squared plus 4. Okay, good to go, everything's fine. Key to this problem is, notice this guy. We factored the difference of two squares into a sum and difference, but the difference happens to be the difference of two squares, meaning x squared minus 4 on its own is x plus 2x minus 2. So the difference of squares will factor into three binomials. And I'll show you one more example of that, and then we'll call it a day. So check, is this a difference of two squares? They both seem like they're perfect squares. There's a difference in the middle. Good to go. 4x squared minus 9, 4x squared plus 9. But again, the binomial on the left is also a perfect square trinomial. The difference of two squares. 2x plus 3, 2x minus 3, and don't forget the 4x squared plus 9 that can't be factorable because it's got the sum and not the difference.